that, but it's just a little further in the notes. And then the last part is organic contamination. Well, the first thing to know is that organic contamination basically comes mostly from airborne absorption. So if you expose a wafer or a substrate to the ambient, organic contamination can basically adhere to the surface. Now, I showed you in the first class that we work in clean room environment, and when you talk about clean, you think, well, great, I'm fine in terms of the ambient, and there's no risk of contamination. But for organic contamination, it's slightly counterintuitive that if you would store a surface, say here, or you would store the same surface in a clean room environment, you see the top part, the peaks are indicative of organic contamination. The bottom part is in the clean room, and you have more peaks and higher intensity. So my clean room is not that clean as you would think. Anybody an idea on why that is the case? Yeah.
Because molecules they migrate to the particles, and a lot of particles.
That will also play a role. I mean, but it's mostly because of the clean room is made up of organic or plastic materials. So there's a lot of plasticizers. There's a lot of, degassing of the materials from the clean room possible. So the concentration in the ambient of organic compounds in a clean room is higher than you would have here in a classroom. We'll have tons of more particles here in this clean room, in this area than in the clean room, but in terms of concentration of the organic compounds, because of the atmosphere, is higher. If you have a higher bulk concentration, you'll also have the reverse effect, so more diffusion to the surface and a higher risk of contamination. So that's what I wanted to say there. Where are they coming from? Well, they are coming from phthalates, esters, siloxanes, which are used from the wall material, which are used from the sealants, which were coming from the HEPA filter. So the HEPA filter is a filter that is used to remove particles before they go into before the air goes into the clean room, but also from some of the processes that we run in clean room environments. We use photoresist materials, which are organic materials with solvents. So there's just a higher background concentration explaining the effect. Organic contamination will absorb on both types of surfaces. Here you see if you have oxygen or other type of moieties in your organic molecule, then they would obviously be more susceptible to surfaces that are hydroxylated. So the OH groups would then form sort of water bridges, and that explains on how the organics are held. Similarly, if you have molecules with less of those oxygen moieties, they would also tend to absorb more on the hydrogenated, so the hydrophobic surfaces. So both the oxide and the non-oxide silicon surface are prone to organic contamination. This is a slide to explain how we would remove organic contamination. Organics, so they can be oxidized. So obviously, if we use an oxidizing process, we will be able to remove organic contamination. And what I'm saying here is a process whereby we use ozone, so ozone as a gas, dissolved in liquid to achieve the cleaning potential. Now we can use ozone in two ways. We can either dissolve the ozone in the DI water and then spray the wafer with ozonated DI water, or we can have a process whereby we have a very, very thin water layer on the surface, which is the right-hand side, and we bring it in contact with ozone gas. Now, the right-hand side process is more efficient than the left-hand side process. And why is that? Well, again, the diffusion process plays a role. We need to have our organics are the red line on the surface of the silicon. Now, ozone is very poorly dissolved in water. We typically would have milligrams per liter of ozone dissolved in the eye water. So we have a very small quantity of cleaning substances available in the bulk of our liquid, which have to diffuse all the way to the surface to oxidize and to do the cleaning steps, so to overcome the chemical bonding of the organic molecules with the surface. Obviously, that is a process that works, but with low efficiency. In the boundary control process, we have a thin layer of water on the surface, but we can bring it in contact with percentage concentrations of ozone. So far more oxidizing species, which will only have to diffuse to a very thin layer of water to do the cleanup, to do the oxidizing process. So this to indicate that not only in terms of the amount of contaminants and the cleanliness of the solution, but also the amount of, or the concentration of the active species that we have available to do the cleaning, that also plays a crucial role in the cleaning process.